How you guys doing? I'll be looking at grading those Module 3 assessments, the 10 questions that we got for you guys, and kind of monitor it, look at it, and get you some reply on that. Moving forward, we're in Module 4. It's the last module here. It's a pretty good one here. It's normally a 2-weeker, maybe a 2.5-weeker at most. But we're looking at Module 4, Chapter 9, which is going to be on short block. I'll be posting stuff up for this week already. I do have some approval to go ahead, and I'm going to go pick up an engine and bring it to my house, and I'll be able to do the rest of the worksheet, which is going to be a piston worksheet that you would have done, and a crank worksheet also. And also where you would actually tear down the whole block completely, all the pistons out, everything bare block, to do some other measurements. But I'll be doing those demos out for you guys, so that way you can see what typically what is done out in the engine repair field, especially in the machine shop business. But we're looking at 184 chapter 9 on cylinder block materials. Just understand that we have different blocks, cast iron blocks as well as aluminum blocks. It's molten metal that comes in place for a type of block unit where they temper it, they heat treat it, and then they micro finish it. And we have different types of areas of the block that you need to be aware of. Of course, the deck surface is there, the coolant passages where coolant's got to be going through, the oil gallery section also that where oil's got to go through, and inside internally on the engine to receive lubrication. And we kind of talked about the reason for that when we had the coolant system section, and then we went to the lubrication system section as well, regarding the need for that in between the holes, in between the block surface as well as the cylinder head, which we just covered on Module 3. We do have main caps also that hold the crankshaft together in place. We're looking at the areas of the crankcase which is below that we look at as well. But typically the cast iron block is of course been used for a long time. When the engines first came out with, of course, then we went with aluminum blocks, which is a little bit lighter, that we see more prevalent on a lot of engines today because of a fuel economy issue, plus they're lighter in material. And we're looking at different types of other scenarios regarding that. Cylinder block, of course, is manufactured by pouring molten metal again. We do have core plugs on the sides of the engine, on the back, front side and back side of the engine. And those are designed, of course, to withhold coolant passages, okay? They call them freeze plugs. You've heard the term freeze plugs, but typically they're called core plugs, okay? We're looking at the types of sleeves that we have on a cylinder block on page 185. Of course, we have a integral sleeve that we'll see pretty much on cast iron blocks, where it's together and machined properly, all throughout the cast iron block system. Then we go to aluminum. Aluminum will have a a type of sleeve that can be replaceable, okay? And you'll see an iron sleeve, cast iron sleeve, installed on an aluminum block type system, okay, which can be replaceable, by the way. And because of the dissimilar metals, what takes place, we produce less friction, and that's why we have cast iron sleeves installed onto aluminum engines, okay? Different types of connecting rods that we look at. Of course, we've got cast and forged, and we talked about the two differences before at the very beginning. Probably show you a demo on that, see if I can get another one. But remember that the cast iron, if you want to know the difference between a cast and a forge, look at the parting line in the middle of the connecting rod. If it's a straight, small line, thin line, it's going to be cast. If it's wide, then it's going to be forged, okay? Forged, we see many used on a lot of course, high-performance engines, and they're durable and they're stronger, and they help with the strength to weight ratio, okay? Titanium, we see some of those connecting rods on exotic cars, more expensive type of cars. They're as light as aluminum, but they're strong as cast iron. So we'll see a lot of those in exotic type cars. And then of course, aluminum connecting rods. We see a lot of those, especially on race car dragsters, funny cars. They like to use aluminum specifically for the fact because it's going under high engine speeds in a short amount of distance. So they have to withstand that. Plus it helps with the expansion inside. The connecting rods, as far as the rod caps go, there's only one way they go because they got an index mark on them on both sides. We talked about, referred to as notch on notch. I'll do a demo on that when I have one apart, so that way you can see what I'm talking about. On page 194, 195. Connecting rods, when we take them off an engine, we have to make sure that they go back in the same direction. So we stamp them on the sides, with the corresponding cylinder. So if it's a 4-cylinder, you're gonna mark them all 1, 2, 3, 4 on the rod bearing and on the rod bearing cap. The connecting rod and the connecting rod bearing cap, they got to be marked the same. So if it's a 1, mark them on both sides. There's stakes, and I'll do a demo on that to show you what I'm talking about because I have them here at my house. And they have to go exactly the way they go. If you take them off, they got to go exactly the way you go, and take them off back into that engine. Okay, they cannot be interchanged between one cylinder to the next. They cannot go in the wrong direction. You can install them, but you're gonna have problems with bearing failure and premature engine wear. So just be mindful on that, and I'll show you that and demo that in my video. Rod bearings gotta have clearance, so we can check clearance with a plastic gauge, of course. Every time we have it machined, we want to check it using plastic gauge. Plastic gauge is a small little strip of gauge, a material that gets installed into the rod bearing journal. When you torque it down, you'll take the rod bearing cap off, and you're going to check the clearance with the chart that's on the plastic gauge setup. And I'll show you that right there. I'll do a demo with that, especially with the crankshaft worksheet. That's a demo coming up with that as well. Looking at piston pin construction, of course, there's a piston pin that goes in between the connecting rod and the piston. Okay, there's 2 types: floating piston and a pressed-in type fitted piston. So the floating piston has 2 snap rings on both sides that link up together and causes the piston pin and the connecting rod to move in and out with a little bit of flexibility. Okay, those right there, of course, a little bit better serving purpose. They're cause less reduced friction and wear and tear, but a lot of them, the only thing is it costs a little bit more expensive to design. So that's why now you'll see a lot of pressed in type piston pins. On those type, of course, there is no clearance, there's no movement on them. Once they get sealed, they're tightly sealed. They do prevent a little bit of friction, but they have a better reduced friction and wear compared to the floating piston pin, okay, because it's very little clearance that takes place in it. That's why a lot of late model vehicles we see today, they're all going with press type fit piston pins. A lot of drag racing engines, of course, they're going to use a lot of full floating type piston pins with circlips on it. We call them circlips, where they look like snap rings on both sides of it, and they're pretty simple to come off on both ends. And then you can replace the piston pin or a piston to a connecting rod with the full floating type system, but not the press fit. Okay, that one requires rod heaters to kind of put together and heat up the connecting rod for about 500 degrees Fahrenheit, and then by the time you take it out, within 3 seconds, you have 3 seconds to literally put the piston pin into the connecting rod and piston in a one-shot deal. Otherwise, it'll harden up on you, cool off real quick, and you won't be able to install it correctly. So it's a certain procedure that needs to be done to it, and if you're not used to doing it, it's going to be a little bit difficult to try and do it the first time. Piston pin offset, that's the difference of where the hole is designed to one side of the piston center line compared to the cylinder. Typically, we'll see that piston pin offset arrow on the top part of the head of the piston, where it'll actually tell us, okay, front here, or an arrow pointing in the direction towards the front of the engine. when you install the piston into the block. You do not want to put the piston with the arrow facing reverse or towards the back end, because that's going to offset that piston pin and you're going to have vibration. You can install it that way, but it's going to vibrate on you. So that's why a lot of pistons on the top part, on the head part, they have a direction arrow, or it will say front. That's why it needs to go to the front. It's because inevitably what's going to happen there is if you install it backwards, you're going to have piston slap, okay? And you will cause premature engine wear with that. Looking at the parts of the piston on page 198, of course, you got the rings, you got the head of the piston, which is crown. Piston is not fully circular and rounded. It gets rounded with heat, but it's typically oval in shape. The piston ring grooves, you'll see there, you'll have slots in there where you'll have your top compression ring, your middle compression ring, and then you'll have 3 rings on the bottom. You got 2 rails and an expander that goes in the bottom. The ring glands are the areas between the ring grooves that separate and support the piston rings as they slide into the piston. Piston boss is very important. It reaches the reinforced area that goes along the piston pin. Okay, that guy gets it's more durable in that area, and it has to be rigid and durable to compensate and to understand that it gets hot and the piston pin can actually waddle if it's not tempered correctly. So the piston boss is a very reinforced area of that boss area, and if it's not durable, compromising of the piston boss between the piston boss and the connecting rod will have an issue where you're going to have noise. So the piston boss is very important. Piston skirt, of course, that's the lasso, the part where the ring goes into. Below that, the piston keeps from tipping its in cylinder. Without a skirt, the piston could cock and jam in the cylinder. So that can cause an issue if it's not chamfered correctly. The different types of piston shapes that we see on page 198. You got a flat top piston, which we see normally on a lot of vehicles, especially with the wedge type of cylinder head, okay, on lower compression engines. Dish piston, you'll see some of those. It's got a crown cave. On page 199, you'll see the illustration on B with a dish piston. Okay, figure 936, you'll see that there. Flat top is there. A, you're going to see that right there with a dish piston, which is for lower compression engines. Then you can see a valve relief piston that we'll see on that particular location, and those are designed where the valves protrude over a little bit further down, so you have to have valve relief there on the piston head itself. And then you got the dome or the pop-up piston that we see on high compression engines. Those are the type that we see quite a bit, and we'll see those on a Hemi head. Okay. Couple other things to look at that we're going to be looking at, seeing that piston clearance has got to have some type of clearance. Okay, otherwise it would freeze up and jam up in between the cylinder, which will cause an issue. Keep in mind that we'll be looking at demoing certain types of 3 different types of clearances that you'll see in my demo that I'll do on worksheet coming up for the pistons first. We'll do a piston worksheet, and then I'll do a crank worksheet for you guys to show you that and do the demos on that for you. There's 3 different ones that we do on the piston clearance measurement, so we'll look at that. Then of course, the last thing, the piston is cam grounded. So in other words, like I mentioned earlier, it's oval shape when it's cold, but when it gets heated up, it expands to become true and round. So only with heat build up inside of it. So keep in mind that the piston, even though it looks perfectly round, it isn't. It's cam grounded when it's cold. And that's helped to relieve the expansion of gases inside, and also to help allow enough expansion when an enlargement with the material type of thickness it becomes between the piston and the cylinder wall area. So that's the need for that, especially for combustion purposes. So look out this coming week, I'm going to be doing probably tomorrow after I get the engine. We'll be looking at doing some demos on the worksheet for the pistons for this week. So kind of stay tuned on that. Hopefully everybody's safe, and we'll look forward to talking to you in a bit.